Welcome to Mathematical Feud. Yay, nice. I didn't have to turn on my applause light. I love it. Remember what we were talking about before the past few days. How can mathematics help us model real-world problems so that we can make informed decisions? Okay? But today what we need to do is we need to introduce some vocabulary. We're going to do it in an unusual way, and we're going to play Mathematical Feud. So in order to play Mathematical Feud, we're going to need our two family teams. So our head of our first team is going to be Bailey. So Bailey, can you come up to the Bailey team? You're going to sit right here. You are head of the Bailey team. Let's clap, please. Let's give her a hand. Nice job, nice job. Thank you. Battling the Bailey team is going to be the Anna team. So Anna, we need you up here. Excellent. A member of the Bailey team is going to be Carson. Come on down. A member of the Anna team, Camden, come on down. Here, excellent. Another member of the Bailey team, we have Ryan. Not you, Ryan, the other Ryan. Female Ryan. This Ryan. Okay, and a member of the Anna team, we have, let's see, we have Maddie. Can Maddie come on down, part of the Anna team? Thank you, Maddie. And last but not least, on the Bailey team, now we have Ryan, the other Ryan Bowser. So we have two Ryans on this team. All right. Twins, excellent. Okay, Maddie, thank you for scooching over. And then on the Anna team, rounding off our Anna team is a Robbie on Anna team. Robbie, come and join her there. Excellent. Okay, teams, this is the way it's going to work. For every correct response, your team gets 10 points, okay? An incorrect response gives you a strike. So if you get a strike, you can have 3 strikes for your team. At the third strike, the other family can steal your points, okay? So if you get 3 strikes, the other family gets a chance to talk to each other and give one answer, and they can steal your points. However, if you don't get any strikes, then you just get all the points for your team. Studio audience, you are going to be the people who decide whether or not their answers are good enough. So you're going to give me a thumbs up, we agree, yes, that deserves a point, or thumbs down, that's a strike. Okay, so you have to make the decision. You have to listen to your team members. Okay, so we are going to start today with, this is our Bailey team, right? This is Bailey team. Bailey, welcome to the show. Come on, stand up right here. All right. Top answers will appear on the board. Bailey, welcome to the show.
Thank you.
Bailey, name, and remember you can't talk, you can't confer yet, but you guys may get a chance to steal. I'll give you a chance. Name a word, or maybe even a couple words, that mean change.
Wait, is it a mathematical word?
That is your choice. You may choose if it's a mathematical word.
Transformation.
Studio audience, transformation. Thumbs up, we agree, that is a good word for change. Thumbs down, no, that's not a good word for change. Transformation. Ding, ding, ding. Studio says yes. So far, team 1 has 10 points. Nice job. Go ahead, studio audience. You may clap for this. There we go. Nice. Thank you, my dear. Next member of the family, come on up here. Carson, welcome to the show. Name a word or words that mean change.
Redo.
Redo is the word chosen. Studio audience, what are we thinking? That is a strike. That's one strike for this team. Thank you. Have a seat. Thank you, sir. Ryan, come on, stand up. Welcome to the show. Welcome to the show. Good to have you here. Ryan, give me a word or words that mean change.
Switch.
Switch. Studio audience. That goes through. Ding, 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 ding. That's switch. Very nice, very nice. So we're at 20 points right now. We do have one strike on the board. Ryan.
Okay.
Okay.
So,
Welcome to the show. Give me a word or words that mean change.
difference?
Difference. Studio audience, we think the word difference means change. Ooh, that got two strikes, two strikes. They have a chance to get to 40 points because there are 4 of them on the team, but they only have one more strike and it comes over to you to steal. Okay? All right, you're back up. Whew, it's tough being head of the family. All right, a word or words that mean change.
To shift.
To shift. Studio. Ooh, this is going to be close. 1, 2, 3, 4. It's just barely by 1. Ding, 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 ding. All right, one more shot for an answer. Carson, a word or words that means change.
Undo.
Undo. Studio audience. It's all coming down to you, bud. Okay, ding, 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 ding. There we go, 40 points. Thank you. Let's give this is the Bailey family at hand. They have 40 points. Okay, so now we are going to head over to the Anna family, correct? The top word on the board wasn't said. Top word for change was vary. V-A-R-Y. How many of you ever heard that word? To vary. Huh. Interesting. So the top answer wasn't chosen. Okay. Stand on up here, Miss Team Anna. I know it's tough being the team leader. Name a word or words that means stay the same.
Indifferent.
Indifferent. Studio. Ding, 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 ding. That's 10 points. Very nice, very nice. Good job. Excellent. What? It's Camden, right? Welcome to the show, Camden. Camden, give me a word or words that means stay the same.
Unchanged.
Unchanged. Studio, remain the same. Unchanged. Studio. Ding, 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 ding. Nice job, Camden. All right, so we have 20 points here towards your 40. No strikes yet on the board. Come on up. Come on up. Okay, welcome to the show. I forgot your name already.
Maddie.
Maddie. Okay, Maddie. Name a word or word that means stay the same.
Congruent.
Got chills on that math word. Congruent. Oh, the ding, ding, ding. Very nice. Maddie, I almost want to give extra points for that one. Right there. Okay. All right, Robbie, welcome to the show.
Hello.
Give a word or words that means remain the same.
Stay.
Stay. Studio audience. Okay, you got to make a commitment in the back. I got to see. Just ding, 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 ding. They have enough points. All right, so it's 40 to 40. Let's give them a hand, please. Let's give Anna Sim a hand. Good job, good job. The top answer did not come up. The top answer was constant. The top answer was constant. Remains the same, constant. Huh, interesting. Okay, so now you have some top answers on the board. Coming back over to Bailey's team. Come on up, my dear. Good job, team. Way to be supportive. Name something that changes or varies.
To slide.
To slide. Studio audience? Tough. Ding, ding, ding. They gave you another 10 here. So we're going to go the points from over here. We got 10. Very nice. Carson, come on up. Name something that changes or is variable. Ooh, change the word vary there.
Vary.
Something that changes or is variable.
A compass.
Something that changes in this world. A compass. Does a compass change? Ooh, yeah. Ding, 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 ding. That was very nice. All right. Miss Bailey, I thought you probably didn't get the whole gist of what I was saying either, but you still did a nice job. And you still got your points. Come on up, Ryan. Okay, Ryan. Name something in this world that changes or is variable.
Time.
Time. Ooh, that is the top answer. Nice job, Ryan. Excellent. Time is very changing. Very good, very good. Ryan, come on up.
Okay.
Ryan, name something in this world that changes or is variable.
The atmosphere changes. So.
The atmosphere. Ooh, we can tell what we are studying in science. Excellent. Ding, ding, ding. Very nice. Good words. Okay, so we have 80 points over here. Excellent. Okay, now we're heading over to Anna's family. Are we ready? Whew, here we go. Anna, top 5 answers on the board. Name something that remains the same or is constant. Name something in this world that remains the same or is constant.
Multiplication.
Multiplication. Survey says multiplication. Does it stay constant or remain the same? Ooh, they buzzed you on that one. Okay. Next, we have Camden up. Name something in this world that remains constant or doesn't change.
Memories.
Memories. Studio audience. Ooh, overwhelming ding, ding, ding. Nice job, nice job. Deal with disappointment. Come on up, Maddie. All right, name something in this world that remains the same or is constant.
How many hours there are in a day?
How many hours there are in a day. Ooh, this is one of the top answers on the board. Maddie, nice job. Yes, number of hours in a day. I bet some of you out there in the studio audience are considering daylight savings. I think that's where some of the brain power is going. Still 24 hours considered in a day, but I love the way your brain was going, I think. Stand them up, Robbie. What do we got? Something in this world that remains the same or is constant.
The text inside a book.
The text inside a book.
Before it's published.
After it's published, clarification. Text inside a book after it's published. 1, 2, 3, 6. There it is. Ding, 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 ding. Very good. Very good. So one more shot. One more shot. Are you ready for your 40 points? Here we go. Go on, Anna. Name something that remains the same or stays constant.
The time of an election.
The time of an election. Studio audience? Can we get some clarification? Do you mean the times that it's open or the
Times like every year they do every 4 years they have another election. That time is constant because every other 4 years there's.
Okay, so she's saying the time between a 4-year, okay. Oh, that changed people's minds. Ding, ding, ding. Very nice, very nice. I think they were thinking about the times it was open. That might be very different. Okay, so we have 80 to 80. Our families were very evenly matched. Let's give our families a hand. Let's give them a hand, give them a hand. What's interesting there is a top answer over here. But there isn't necessarily a top answer mathematically for things that change because they can be anything. I mean, isn't it hard to think of something constant because you can think of that one situation where it might change? Where this group here, remaining constant in mathematics, the top answer is numbers. 4 represents 4. That's what it represents all the time. That's constant. 4 items is 4. Okay? But Things that change, well, there's a lot of those. Nice job. Let's give our families a hand as they head back to 2 new mathematical words that are really, really important. They're the base words for algebra. So we're getting ourselves ready for real true algebra. Those are the 2 words that we were using. Does anyone remember what the two, could you hear them when I was saying them? What are the 2 mathematical words that we had? How about the gentleman way in the back in the blue?
Very and constant.
Okay, very good. Very and constant. And then we take the word vary and make it, I guess, would that be an adverb? I don't know. Variable is what we use. So we're going to get those 2 words into our journals today. We have the word variable. So say it with me. Variable. One more time. Variable. Okay, sometimes people say it incorrectly. It's V-A-R-I-A-B-L-E. You can see the word vary there. They just changed the Y to an I to make it variable. The word variable, as you probably guessed from Family Feud, means something that changes. Okay, something that changes. So you can write your own definition, you can write my definitions, up to you, from what you heard today. So we say it's represented by a letter, and we're going to look at that, but it's a changing value. It's something that changes. It's also something that's unknown. Okay, it's something that changes, or it's an unknown. So when our family group was up here and I was asking them for things in this world that change, we said a compass, because it can spin, it changes. You don't know where it could possibly land at that moment. Other things, time. Time's changing all the time, right? So there's lots of things that change. They are variables, things that you can't always know exactly what it is going to be. The other word, as you got, was constant. Say it with me, constant. Constant. Thank you, constant. C-O-N-S-T-A-N-T, constant. And in mathematics, we say that's a value that doesn't change. Constant is a value that doesn't change. We also said in our Family Feud, something that remains the same. Something that remains the same. Because math has to represent the real world, math is one of our real world models, we have to have things that represent something that changes, and we have to have things that represent things that don't change. Okay? So we have to be able to model both of those situations. The constant, the things that don't change in mathematics, are numbers. 6, 8, 12. Those are all constants. So in math, we represent constants with a number. That's why here under the example, I wrote 4 plus m and put my arrow at 4 to show you that 4 is the constant. In mathematics, to show somebody when they look at it, this is something that changes, we use a letter. We represent things that change with a letter. So if I wanted to represent a compass spinning, I would use a letter. Maybe the letter C. I don't know, for compass. Time, what do you think I'm going to use?
T.
Nice. T, yeah. But mostly in mathematics, we use the letter X. The letter X in mathematics, we use that for a variable a lot because not as many words start with the letter X as every other letter. It's the least used letter at the beginning of a word in any letter of the alphabet. So that's one of the reasons why X is used the most. Okay, so I wrote an X plus 3. 3 would be the constant. X would be the variable. Okay, things that change. All right, let's try. I want to write up a little problem. I want you to write the problem with me, if you don't mind. And we'll take a look at what's variable and what's constant. See if you can figure it out. We will use my person Jonah. Jonah invites friends over. After school for snacks. I don't like that. That didn't come out real well. So Jonah sounds like a pretty cool friend. You might want to make friends with him. Each friend that comes over gets 2 cookies each. Jonah's a good friend. So Jonah invites friends over after school for snacks. Each friend that comes over gets 2 cookies each. I guess the word each is in there twice, huh? Yeah. We mean it. There's that. How many cookies will he need for 4 friends? This should be something you should be able to do pretty quick. Nice. What do you think, bud?
I think he'll need 8 cookies.
Okay, so tell me here, what's variable? What's changing?
The number of friends.
Excellent. The number of friends, we have no idea. That's the unknown. That's our unknown. We don't know how many friends. Is there anything else that might be possibly changing? Liam, what do we think?
Well, like, if Jonah eats any cookies, because
That's true. That's a variable. Does Jonah count as one of the cookie eaters? That's very good. Excellent. That is variable. That's true. Jonah, we're not even sure about Jonah. Is he a variable or not? It's Tristan, right?
Yes.
Tristan, what do we think?
Well, what I was thinking is, if I'm correct, how many snacks does she have?
You mean total?
Like total of cookies.
Very true. We don't know how many cookies they could have. 20 boxes? You know, Girl Scouts could have jumped in on this household, or it could just be a couple that Mom made. Who knows? Sir.
How many cookies he has after his friends leave?
Nice. So cookies it's a variable before, it's a variable afterward. We're not sure. What's the constants? Where are the constants locating? Ryan, what do we think? What are the constants? Young lady Ryan, sorry.
at the end, the amount of friends that we find.
Okay, so this constant, 4 is 4, right? Maddie, what do we think?
Another one is
2
2 cookies.
cookies. Because 2, that's going to be, we know you get 2, we know that there's 4. Some of you think there's more constants. Camden, what do we think?
Each friend.
Pardon?
Each friend. Is
Understandable. Yes, this part here, this is definitely the constant. You're right. Each person gets 2. That's constant. Excellent. Sir, what do we think?
The fact that he invites them over after school.
That is a constant. That's correct. That isn't changing. You can't invite them during school. They're not coming. Okay, so there's the constant. What if I said he has 5 friends? What's changing? Sir, in the blue and the yellow.
You speak in mathematics, the variable is changing, but also the number of cookies that he needs is changing.
Good.
And also the number of friends.
So we have the total cookies is changing. The friends, those are the variables, right? Those are changing. Okay. Is he still going to give 2 to each person?
Yeah.
It's constant.
More of each.
He just needs more because of the total. Excellent. What about if he has an unknown amount of friends at the end? It's kind of a weird question. Sir?
He would make a lot of cookies and then find out how many friends he has.
Well, then how many friends you can make. You can work backwards. That's an absolutely perfect model. Cookies. How can we represent when we don't know how many friends? How can we represent the number of friends? I haven't heard from you yet.
You could represent it as a variable, like a number.
Can we use a number?
I mean a letter.
Okay, so give me a letter for the total friends.
X.
Perfect. You can also use F. You can use F, you can use N. You'll be surprised in mathematics. Usually in textbooks they use a lot of different letters, but in true mathematics we tend to see to use X, N, M. We stay with those letters more than anything. Y, Z. Those are the ones we use the most. Ryan.
Well, you could say how many friends do I have, and you could make as many cookies as you have friends, or double it, and you would say, okay, you guys didn't show up, come back next time.
That's true. So what are you doing here? You're modeling something in the real world. Algebra sometimes works backwards, like you just said. Sometimes it works forward. Like we're not sure how many versus we know how many friends and now we need to work backwards. That's the beauty of algebra. You get problems in the world, there's so many of them that we have to be able to model them somehow. So right now our purpose of modeling is we're going to model things that stay constant and things that change. Okay? That's basically the world right there. Things either change or they stay constant. So what I want you to think about right now, I want you to have a discussion with a partner discussion real quick. The video you watched the other day of getting to the volunteer shelter that you're going to volunteer at. Okay? Think about that for a moment. You came up with times or factors that could cause problems of getting there at different times. I want you to decide with your shoulder partner what of those things were variable and what were constant.